This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2018 AP Calculus exam, free response question AB5. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading. I'll present a brief general summary for student performance on this question, and then I'll consider more detailed interpretations of the scoring guidelines, and how these guidelines were applied in certain situations. I'll consider some common student errors where it's relevant, and where appropriate, I'll present some specific scoring examples. This problem initially involves a function f defined by e to the x cosine x. In part A, we need to find the average rate of change of f on the interval 0 to pi. In part B, we need to find the slope of the tangent line to the graph of f at x equals 3 pi divided by 2. In part C, we need to find the absolute minimum value of f over the interval 0 to 2 pi. And in part D, a new function g is introduced. We know that g is differentiable. We have the value of g at x equals pi over 2, and the graph of g prime is given. We need to use all of this information to evaluate the limit of a quotient. Part A was worth 1 point, simply for the answer. However, the supporting work presented must be correct. Part B was worth 2 points. The first point was for finding a general expression for the derivative of f, and the second point was for evaluating this derivative at x equals 3 pi over 2 to find the required slope. Part C was worth 3 points. The first point was a conceptual point, for knowing and writing f prime of x is equal to 0. The second point was for identifying the two critical values, in this case two values where f prime of x is equal to 0, as candidates for x coordinates where the absolute minimum value occurs. And the third point was for finding the absolute minimum value and for providing sufficient justification for the answer. Part D was worth 3 points. The first point was for recognizing and for stating that g is continuous at x equals pi over 2, and for confirming that both the limit of the numerator and the limit of the denominator are 0. The second point was for applying L'Hopital's rule, which really means taking the limit of the quotient f prime of x over g prime of x. And the third point was for the final answer. Note that the student could earn a maximum of 1 out of 3 points in Part D if they did not sufficiently communicate L'Hopital's rule by writing the limit of a ratio of the derivatives. In Part A, most students were able to write a correct difference quotient, evaluate the function f, and earn this point. However, there were some common errors. Some students found an average value of the function f over the interval 0 to pi. Some students found an average rate of change of f prime. And remember, this was not a calculator active question. However, some students presented an incorrect decimal approximation for pi that resulted in an incorrect answer. In Part B, most students knew that they had to find the derivative of f. However, some students did not apply the product rule correctly, and some had difficulty finding the derivative of e to the x and/or the cosine of x. And there were some errors in evaluation of the trig functions sine and cosine at x equals 3 pi over 2. In Part C, most students understood the concept of critical values. Well, at least to consider values where f prime of x is equal to 0. However, many students had trouble solving this equation, that is, finding the critical values, and many found only one critical value. Note that in this problem, there were no values where the derivative does not exist, but students were not obligated to address this issue. Now, many students had difficulty with the justification, and especially in presenting a global argument. And many considered only the critical values in their argument, ignoring the endpoints of the interval. And some students used poor communication, a local argument, or simply miscalculated values of f. In Part D, most students did not state that g is continuous, since g is differentiable. This property of continuity was necessary in order to evaluate the limit as x goes to pi over 2 of g of x by direct substitution. Unfortunately, many students did not use correct limit notation, and some students inappropriately equated this limit to its indeterminate form as a way to communicate that L'Hopital's rule can be applied. In Part A, we need the average rate of change of f over the interval 0 to pi. And although we're looking for just the answer here, any supporting work presented by the student must be correct. Here are some example responses and the score for each. In example 1, we don't need to see the minus 0 in the denominator. This response earns the point. And contrast this with example 2. Here the student has not evaluated the function f. This does not earn the point. Examples 3 and 4 both earn the point. There is a final numerical answer presented, and so it doesn't need to be simplified. In example 5, if that's all that's presented, this expression is correct, and it earns the point. And in example 6, some students think of the average rate of change of f in terms of a definite integral, and this is a valid mathematical approach, and it earns the point. In Part B, the first point was for presenting a correct expression for f prime of x. Here are some examples and the score for each. In example 1, the correct first derivative is presented. This earns the first point. In example 2, the only thing presented is the correct answer, the slope of the tangent line at x equal 3 pi over 2. Now, we didn't ask for f prime of x, so the student is not obligated to present this general function. This response actually earns both points in Part B. In example 3, notice that there is a sign error. This response does not earn the first point, but we'll still read with this student for an answer. And there were other sign errors such that the student was still eligible for the slope point, and these are presented on the next slide. In example 4, if this is all we see on the page, it earns 0, 0. However, this could be a presentation error, a missing set of parentheses. If the student clarifies this presentation error, they earn the first point and are eligible for the second point. The second point in Part B was for the slope, and there was an eligibility criteria here. The first derivative f prime must be in this form. Here's a table with these 4 possible forms, the resulting slope, and how each was scored. Note that some students presented the equation of a tangent line as their final answer here, and I think we had a fair procedure for scoring these responses. First, the second point was awarded if the student used the correct slope in the equation of a correct tangent line. If the correct slope was declared, say m equal e to the 3 pi over 2, and used in an incorrect tangent line equation, the student earned the second point. However, if the student declared the correct slope and then clearly identified an incorrect tangent line equation as their final answer, They did not earn the second point. The first point in Part C was for setting f prime of x equals 0, or really, for sufficiently conveying this conceptual idea. Here are some example student responses and the score for each. In example 1, the student earns the first point. In example 2, even though we don't see f prime of x equals 0, this expression that's presented is a result of solving this equation, and it earns the first point. Similarly, in example 3. In examples 4 and 5, the student has conveyed the conceptual first step here in words, and so each earns the first point. In example 6, suppose the student calculates the derivative incorrectly. If they still identify their expression as f prime and set it equal to 0, they earn the first point. However, in example 7, an incorrect first derivative, unlabeled or undeclared, set equal to 0 does not earn the first point. The second point in Part C was for identifying x equal pi over 4 and x equal 5 pi over 4 as candidates for x coordinates where the absolute minimum value occurs. And there was also an eligibility criteria here. The student's first derivative must be of this form. Here's a table of these four forms, the x-coordinate candidates, and how each response was scored. Note that if the student presented additional x-coordinate candidates in the interior of the interval, they did not earn the second point. And candidates might only be presented in evaluations of the function f, and that's okay. The student can still earn the second point. The third point in Part C was for the answer with a sufficient justification. To be eligible to earn this point, the student must have a correct expression for f prime of x and have earned the second point. To earn this third point, the student must identify the minimum value and present a sufficient global argument, for example, a table of values. Now again, the minimum value must be identified or marked in some way. And in the table of values, if any function value is incorrect, the student does not earn this third point. The remaining three candidate values do not need to be explicitly evaluated, but the student must indicate that they are positive. The minimum can be identified as a point, but the student still needs a correct justification. Just reporting where the minimum occurs is not enough. The question asked for the absolute minimum value. Now, it's possible to exclude x equal pi over 4 as a candidate with a correct verbal argument. Some students were successful at this. And local arguments are not sufficient to earn this point. In Part D, the first point was for concluding that g is continuous at x equal pi over 2, and for demonstrating the limit of the numerator and the limit of the denominator are both 0. Since g is differentiable, g is continuous. And this property of continuity is necessary so that we can evaluate this limit by direct substitution. Although not strictly proper notation, if the student presented this type of expression with the arrows and indicated that g is continuous, they earned the first point. However, equating the limit to its indeterminate form did not earn the first point. The second point in Part D was for applying L'Hopital's rule. That is, for using correct notation to convey the proper mathematical process. And an imported incorrect derivative can be used here and still convey that you're applying L'Hopital's rule. But we really need to see a limit attached to a ratio of derivatives, and here are some examples. If the student did not write x goes to pi over 2, they could still earn this second point with other supporting work. For example, if they presented the quotient f prime of pi over 2 divided by g prime of pi over 2. And note that if the student did not use limit notation properly, that is, they did not convey L'Hopital's rule correctly, they could earn a maximum of 1 out of 3 points in Part D. The last point in Part D was for the answer. And the eligibility? Well, they must have earned the second point. And an imported incorrect f prime of x may still earn the third point. So let's suppose the student has earned the second point. All of these versions would earn the third point. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. There is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.